Hey, fifth graders. Okay, so I'm back in the classroom, obviously. I needed to come in because I wanted to do the math packet stuff that I sent home for you. So this is the getting ready for sixth grade work that we probably would have been roughly starting now, actually. I think that with the pace that we were going through things, you probably would have been, well, I guess now is relative because you could be watching this in the middle of, September or something, and so whatever. But anyway, so I'm going to teach the first two lessons, basically, I think is how this is going to work. Yeah, the first two lessons are very closely related to each other, so I'm just going to kind of do both at once, and then I'll have videos for the other stuff later. Hopefully you didn't freak out too much when you looked at the title of this, which is Compare Fractions and Decimals, because some of you, not all of you, but some of you really struggled with fractions and decimals, and then now I'm throwing them together for you to have to deal with both of them at the same time. And in addition to that, there's a number line on here, which is this group's favorite thing in the whole world. Again, some of you understand number lines perfectly well, some of you not so much. But we're going to get through it. It'll be okay. So the first thing is, this is unlocking the problem, right? So I'm just on lesson 1, page 1, which I guess is GR1 for our purposes here in this packet. It says the tech club compared the weights of 3 cell phones. Esteban's phone weighed 4.7 ounces. Jill's phone weighed 4 3/5 ounces. Mona's phone weighed 4.35 ounces. Who has the phone with the lightest weight? All right, so they also talk about benchmarks here at the bottom, and they show you the benchmarks. Really what the benchmarks are is, just like we talked about way back in both our fraction and our decimal lessons, is it's going to the quarter. So think of it, quarter is money, right? Or we can think of quarter as 1/4. So if you're counting by 1/4, you go 1/4, then you have 2/4, which is equal to 1/2, then you have 3/4, then you have 4/4, which is equal to 1/2. Okay, so those are our benchmarks for fractions. For decimals, it's again quarters, but this time it's quarter like money, 0.25. If you have 2 quarters, you have 0.50. If you have 3 quarters, 0.75, and 4 quarters, of course, is 1/2 or 1.00. So yeah, those numbers are related, and we talked about this a little bit in class. But if you have 1/4, right, that's equal to 0.25, and that's all we're doing here for these lessons, right? So 1/4 is 0.25, 1/2, which is 2/4 equals 1/2, which equals 0.5 or 0.50. 3/4 equals 0.75, and then 4/4 is equal to 1.00. All right, pretty straightforward, pretty simple stuff. Now we're going to get into some things that are really not much more complicated, but I do want you to keep those benchmarks in mind, just because they are, well, first of all, because it's going to ask about it, but second of all, just because it's easy to sometimes round to the nearest 1/4 or the nearest quarter, and from there kind of get a ballpark answer, and that can really help you. So in terms of what we had here, and I know that they obviously have the numbers kind of like pointed out for you, but this is what I'd like you to kind of look at it as. All right, so we've got, actually let's do different colors here. Let's do red and purple. All right. So Esteban's phone weighed 4.7 ounces. 4.7. Now, 4.7 is the same as a fraction. It's so hard to see it. I apologize about the glare on this. It just is what it is. I can't fix it. So 4.7, another way of saying 4.7 is 4 7/10. And if I asked you just to write 7/10, some of you, hopefully, would write 7/10, like that. Okay? So this, 4.7, is 4 7/10. All right, so now we've already got fractions that are equal to each other. Our next one, sorry, I have to step closer here, is 4 3/5. oops, so I'm going to do fractions in red. So 4 and 3/5. And now here, notice here I just put the 7 over a fraction, right? So you might be tempted to think, oh, I could just use this and we could say that it is equal to 4.3. But this is 3/10 and this is 3/5, and those are not the same number. So we can't do that, that's not okay. What we could do in this case though is 4 and 3/5 is 4, and we can find a common denominator here between fifths and tenths, which is tenths. So we're multiplying this times 2, right? Our denominator times 2 is 10. So whatever we do to the bottom, we have to do to the top. So now we're going to go 3 times 2, which is going to equal 6. So 4 and 3/5 is equal to 4 and 6/10, which means this could be 4.6, because this is 6/10 and that is 6/10, so it's the same. All right, and our last one was 4.35. Now this is where, now 4.35 doesn't work very perfectly with transferring it into tenths, right? Because this is 3/10, but there's also 5/100ths that are with it. And for right now, and probably for a very, very long time, I don't want you doing something like 3.5 over 10. Okay, just, that's not a good idea. Let's not get into that. But this is the hundredths place value, right? Which means this is 35/100ths. 4 and 35/100ths is how we can say that number. Which means we could write it like that. 4 and 35 over 100. And you can do this with any fraction, right? You can start off just by putting it over whatever the place value is, the number the farthest to the right is. So if this went 4.351, we could have made this 1,000 and it would be 351 thousandths, and that's a good place to start. Of course, this causes problems here because now we've got hundredths and we've got tenths, but fortunately it's really easy to switch between these two because all we do is we multiply the bottom times 10 and we multiply the top times 10. And we do the same thing here. All right, now we have all of our numbers with common denominators, and we can really easily compare these fractions, okay? And also we've converted our one fraction that we started with into a decimal, so it's easy to compare it from that direction. So you can do it 2 different ways, doesn't really matter. You can even have simplified this and just go crazy with it, but it's all good. Yeah, so this is, I guess, kind of one way to start. Now, on the number line, of course, all of these numbers are going to fall in between, let's see here. All right, so if this is 4, and we make this 4.5, and we make this 5.0, and I realize that they give you a number line, and that number line happens to be going up by, I believe, 55, 60. Yeah, it's going up by 5/100ths each time for each line. So you could really easily put the numbers on that number line. But for our purposes here, we can say, okay, well, we know this one is going to be, let's see, about halfway is about there. That's 4.25. And then we just go 5, 10, 15. Okay, not very good spacing that out. And it occurs to me now that I've got my decimals in red here and purple up here, but it is what it is. All right, so that's 4.30, 0.35, 0.4, 0.45, 0.5. All right, so we go 30, 35. So it's going to be right here is 4.35. That's that number. And we've got our 4.6. So if we go kind of halfway in between, that's like right here. And again, we're just going to go that. So this would be 4.55, and this would be 4.60, which is what we've got up here. However, we could write it up above as 4 3/5. Okay, and then the last one is 4.75, or 4.7, sorry. So that one's going to be right here. Okay, and hopefully that's visible to you guys. Looks like it is. Yeah, so this is just putting it on the number line. Fairly straightforward, simple stuff. So let's take a look at some problems actually from it. All right, so they give you a number line, and they ask you to find, and again, the increments there are 0.05 or 5/100ths. Okay, and then they want you to identify, all right, what is the decimal at point A? So let's see, I don't want to do that. Okay, so I just real quick drew this thing rather than dealing with triangulate, and I made it all nice and pretty, and it was a whole thing. So here we are. So questions 1 and 2 using this number line. All right, so I've drawn the number line out. You'll notice that there's the benchmarks on the bottom, the benchmarks on the top, though one of them appears to be missing, so I wonder what that number is worth, or that decimal, or that point, I guess, is worth. So first of all, question 1 says point A written as a decimal point, all right? So it is right there, okay? So it's just a little bit before 0.75 or 75/100ths. So a couple things. Since this is a number line, we could count what this is and kind of figure out, okay, what is each one of these little distances here worth? So if we go 1, 2, 3, 4, 5. All right, so it's going to go 5 from here to here, and it has to gain 0.25. Divide that by 5, you find that each one of these is worth 0.05. So this distance here is 0.05, okay? Which means that this one is 0.55, this would be 0.60, 0.65, and so this is 0.70, and then 0.75, all right? So A is equal to 0.70. And if we were in class and talking about this, I'd make you guys write it as a fraction as well, which would just be, you'd say, okay, well, this is 7/10, or actually it's 70/100ths, but that's the same as 7/10, so you can just write it as 7/10, like that. Okay? And then B happens to be right on that 0.25. It is halfway in between 0 and 1/2. So B, of course, is going to be equal to 1/4, which is the same as 0.25. Okay. So point B written as a fraction, that's that right there. And then it wants to know which one is greater. Well, that's pretty easy to see. You know, first of all, just looking at the number line, right? Like here's 0, here's 1. B is closer to 0, A is closer to 1. Obviously, point A is greater. Okay. Additionally, you know, 0.70 is bigger than 0.75. So pretty straightforward there. Let's see. Let's look at number 3 then. And yeah, all right. Oh, I spent all that time writing that number line and then I just erased it right away. Okay, so number 3 gives us 3 different numbers, and then it wants us to tell what the number with the biggest value is, or the greatest value is. So 0.55, 2/5, and 0.46. Okay, now, hopefully that's visible. I apologize, using the blue is maybe a mistake. So really what you need to do, kind of like when we find common denominators when we're comparing fractions, is get all the numbers to be decimals. That's honestly the easiest way to tell. If we were to write this, so if you were to write 55/100ths as a fraction, it'd be 55 over 100. Then you could simplify that and say, well, 5 goes into 100, so you're dividing both, oops, not by 2, but by 5. All right, so then we get 11 over 20. and we're going to compare that to 2/5. You know, we can. It's going to involve finding common denominators there, and we haven't even gotten into this one, which would be 46 over 100. Let's see, we can divide by 2 at least, which is going to give us 23 over 50. So now we've got 50ths, 20ths, and fifths. We got to find, really, we're just going to have to make them all hundreds at that point. Not very pretty, right? Like it's a little bit messy. Instead, what we could do is say, okay, let's just turn this 5 into tenths. And they give you a lot of numbers as fifths because they want it to be easy, all right? So turning this into tenths, we got to multiply by 2 here, which means whatever we do to the bottom, we do to the top, right? So this becomes 4 over 10. So 2/5 is equal to 4/10, okay? And then 4/10 written as a decimal is 0.4. All right, super easy to do it that way. Now you can probably look at these and see, okay, so we've got 55 hundredths, we've got basically 40 hundredths, let's say it that way, and we've got 46 hundredths. So which number is the biggest or has the greatest value? Well, it's obviously 55 hundredths, or 0.55. All right. All the rest of these are pretty straightforward after that. Cool. Yeah, those are all, the rest of them are pretty similar. If you know how to do this, if you've been following along, you get it. You shouldn't have too many problems. If you do have problems, always feel free to join me on my little Google things and Google Meets, and we can chat about it. So the next page is kind of more of the same, only this time what they want you to do is they want you to put the numbers in order and pay very, very careful attention. So it goes sometimes from least to greatest and sometimes from greatest to least. And even I, while I was doing it, have one that I was like, oh, just kidding, did that one backwards. So just pay attention. So number 1, they want it from least to greatest, but then 2 and 3 is from greatest to least. 4 and 5 are from least to greatest, then 6 and 7 are from greatest to least. So they're kind of flipping back and forth. Honestly, I don't really care so much if you get them in the proper order that it's asking for, as long as you can get them in a proper order, right? If you always went least to greatest, like, okay, yeah, technically it would be wrong, but the important thing is that you can compare these. So as long as you can do that, really it's okay. So let's take a look at number 1 here. So they wanted you to locate it on the number line. We're going to skip that part. So for number 1, this is on page GR4, by the way. Oh, okay, so we'll circle this. Number 1. All right, we've got 3/5. We have 0.54, and we have 0.35. Okay, and we have to figure out, okay, you know, how do we line these up? Well, again, as I've said in the last lesson, the easiest thing to do is really just to turn the fractions, especially if you have a fraction that's got fifths down there. Anything really that you can multiply to get to either 10 or 100 is generally easier to go and make decimals. Okay, we could actually, let's talk about this real quick because I don't think that they all work out. Let's see. Yeah. All right. So we're going to get into numbers that are not so pretty. So let's talk real quick while we've got an easy one. So 3/5, you probably could guess if you multiply fifths times 2 and you multiply that 3 times 2, you're going to get 6/10. Does that show up better? Okay, well, actually let's do it below. That way it's away from the glare. All right, so you've got 6/10, right? And if you write 6/10 as a decimal, that's 0.6, okay? So 3/5 is equal to 6/10, which is equal to 6/10, though written as a decimal. But we could have found this in a different way. So what you can do, we talked about in class that fractions are division, right? So really what this is saying is 3 divided by 5. And probably more than a few of you looked at that problem and like cried a little bit inside because you're not remembering way back when we did this as part of our decimal unit, because you'd say, oh wait, 3 doesn't go into 5, I need to flip those numbers. But no, don't do that. That's not how it works. All right? Remember, we can just put a decimal, add a 0, and then just carry on with our merry old ways. 5 goes into 3 0 times. So bring up that decimal point. 5 doesn't go into 3, so it's a 0. Then we say, okay, how many times does 5 go into 30? Well, you should all immediately be able to say 5 goes into 30 6 times. 6 times 5 is 30. We don't have a remainder, so 0.6. So see, those two are equal, and you can get there in 2 different ways. Now this is important because we're going to have numbers that do not work pretty with like making them a 10 or 100 or something like that. So, for the purposes of question number 1 though, we've got basically 6/10, right? That's 3/5. We've got 0.54 and 0.35. So if we wanted to write those numbers in order, from least to greatest is what they want this time, we're going to go 0.35, 0.54, and 3/5. Okay? So that's the order that those numbers would go in from least to greatest. All right. The next two. Okay, let's take a look at number 3. We're going to kind of tackle the ones that have weird fractions that you guys aren't going to be used to. So I'm going to assume that fifths are pretty easy to make into decimals. Fourths and halves are kind of the same thing, right? You guys are all used to 0.25, 0.5, and 0.75, right? That's all straightforward for you. But when we talk about eighths, now we're talking about, so 1/8 is 1/2 of 1/4, right? So that's where it gets a little dicey. All right, so for number 3, what we're looking at here. Shows up, okay, good. We've got 5/8. We have 0.5. We have 2/5, so an easy one. And then we have 0.78. All right, straightforward. So, first of all, let's just right off the bat, let's take a look and see. Okay, number 3, the instructions say greatest to least. So we want to start with a big number and work our way down. So let's go ahead and we're gonna change this one right away into 4/10, right? Because 5 times 2 is 10, 2 times 2 is 4, and 4/10 is equal to 0.4. So we already have that one out of the way. We know that it's less than this and it's less than this, so it's pretty small. In fact, we could arguably say that it should be our last number because we're going from greatest to least, because this is 1/2, right? 0.5 is 1/2, and 5 is greater than half of 8. So this number is going to be bigger than this number, and this number is already bigger than that number. So this one's going to come last, and then this one will be next, and then we got to figure out, okay, which is the greatest between these two is really where we're at. Now, there's 2 ways to figure out eighths. Probably one of them is simpler than the other. Though it's really going to depend on what you prefer. So 1/8, I said, is 1/2 of 1/4, right? And we talked about 1/2 times 1/4 is 1/8. You guys hopefully remember that from when we were multiplying fractions. Okay, now that means that it is 1/2 of 0.25. So we need to cut 0.25 in half, right? Or we could say that it is 0.5 of that, so we can go 0.5 times 0.25. All right? Now, if you work this out, you're going to get 0.125, okay? And if you think about it, so if we just kind of ignore the 0 point, so we've got 12, right? Or we have 25. If you cut 25 in half, okay, you're not going to have a whole perfect number. It's going to go into the decimals, right? It's going to be 12.5. So 0.25 makes sense that it'd be 0.125 as your 1/2. So we could know this, and you could just memorize this one number and then multiply whatever the numerator is times 0.125 to figure out 5/8 or however many eighths as a decimal. So actually, let's just do that. All right. So 5 times 5 is 25, carry over 2. 5 times 2 is 10, plus 2, carry over 1. Sorry, it's 12, carry over 1. 5 times 1 is 5, plus 1 more is 6. We have 1, 2, 3 numbers to the right of the decimal point, which means we need to go over 1, 2, 3, 0.625, okay? So you could figure it out that way. That's one option, and that's right. The other way, of course, is to say 5 divided by 8. Well, 8 doesn't go into 5, so we have to go into the decimals, which we already knew is going to be less than 1. All right, so 8 doesn't go into 5, so we put a 0, bring up our decimal point. Now 8 goes into 50 6 times, which is 48. 50 minus 48 is 2. We're going to have to add another 0 because we still have a remainder. 8 goes into 20 twice. 2 times 8 is 16. So we have 4 left over. So we still haven't reached our perfect number, right? So we're going to add another 0, bring it down. So 8 goes into 40 5 times. 5 times 8 is 40. Now we have no remainder, which means that we're good to go, all right? So we are at, again, 0.625. Okay? Hopefully this makes sense. If we were in class, I'm sure I'd have a number of people who were telling me that that doesn't make sense, but since it's just a YouTube video, we're just going to have to make do with it as is. All right. So now we have all our numbers, and we need to go from greatest to least. Well, 0.625 is less than 0.78. So that's going to be our first number, 0.78. And this 0.625 is bigger than 0.50, so next we have 0.625. Then we have 0.5, and we have 0.4. All right, so that's the answer to number 3. The only other one that I want to talk about, just because, again, it's a little bit on the tricky side, is, let's see, 5th, 4th, 5th. Okay, so let's talk about thirds. All right, now, I'm not actually going to get into the answer. You'll deal with thirds on number 4 and number 8 on this page, and on the back page, you deal with 6th on the back page. Okay, so let's talk about thirds, and then we'll talk about 6th. How about that? That'll be fun, right? Yeah, totally. All right, so this is almost one that it's just easier to memorize than anything else. So 1/3. Well, let's divide 1 divided by 3. All right, well, 3 doesn't go into 1, which we knew because it's less than 1. We're going to have our 0. All right, so 3 goes into 10. Well, it goes in 3 times. 3 times 3 is 9, which leaves us with 1. Anytime you run into this thing where you're basically creating, because now we're going to add a 0, and you created the number that you started with originally, right? We started with 10. Now we're back to 3 goes into 10 how many times? That means that you are in a loop that will never end. Okay, it will forever repeat that same number, right? Because this will be 3. 3 times 3 is 9. Again, we subtract. That leaves us with 1. We add a 0. 3 times 3 is 9. 0. Oops, sorry, not a 0. 1. Then there's a 0. 3 goes into 10 3 times. And hopefully you can see where this is going, right? Forever, forever, forever. We can just write 3s to the end of the board, off the edge of the board, or maybe start back over at the beginning. 3, 3, 3. It will never be not 3. Okay? Now, for our purposes, basically you can just stop at the second 3. One way that people show this, I'm just going to erase these other ones, is they just put a little line over the last one, and that just tells you that, hey, this repeats forever. It never stops, okay? And sometimes you run into situations where you might have something that goes, I don't know, like 4, 5, 6, 4, 5, 6, 4, 5, 6, 4, 5, 6 forever. So then you just put a line over 4, 5, 6, and people would understand that, oh, it just keeps repeating those numbers again forever. All right? So, but if you just go to 0.33 for our purposes, that's pretty good. Now, what if instead of 3, or instead of 1/3, we had 2/3? Okay, well, now it's obviously not going to be 3's. So we have a 2. Well, how many times does 3 go into 2? Well, it doesn't go in at all. How many times does it go into 20? It goes in 6 times, because 6 times 3 is 18. And then, we end up with a 2, drop down to 0, we're back to 20. This is going to be 18, which is going to give us a 2, through 18, 2, 0, 18, etc., forever, right? So again, you can just do 0.66, put a little line over it, and then just understand that it's going to be 6's forever. And I'm sure because Catholic school, you guys probably were worried that I was going to do 0.666, and then like, oh no, it's the sign of Satan or something. I don't know, maybe thirds are Satan's number or something, but in this case, it just happens to be a number that repeats forever. It happens to be a number that is, associated with badness. But yeah, so 0.66 repeated forever is 2/3, right? So for thirds, it's almost easier just to remember. So 1/3 is equal to 0.33 forever, and 2/3 is 0.66 forever. Okay, almost easier just to remember that. Okay, not too hard. Now there is a problem on. Okay, so it looks like it's only a problem on the homework, which is kind of a terrible thing to throw at you there, but whatever. Which is going to involve 1/6. Okay. Fortunately, though, you can solve this just the way I've shown you the last several of them. And 1/6 is not going to come up just the one time. I don't know how many times it's going to come up. I don't know if it's really worth memorizing. But that's okay. So we've got 1. We're going to divide by 6. So this one kind of does a little bit different of a thing. Obviously, 6 doesn't go into 1. 6 goes into 10 one time, right? Put down a 6, subtract, we've got 4. Okay, well now we're clearly not going to end up at 10, so that's not so bad, right? Okay, yeah, no big deal. Put a 0 there, we're writing it down. 6 goes into 40. Well, 6 times 6 is 36. Uh-oh, notice we ended up with 4 here. Now we end up with 4 here. Okay, so we've got another 0. 6 goes into that 6 times, 36. And we're back in a loop, okay? So 1/6 is equal to 0.1666666 forever. So now here you can't do that, right? Because it doesn't repeat the 1; it just repeats the 6's. So you could do something like that. That would be fine. It just goes forever. 0.16. You can do 0.1666. However many times you want to do 6's. But yeah, that's really the only time that's going to come up, at least that I've seen in the first couple of lessons. So on lesson 2, just remember that you pay attention to whether or not it's asking you to do least to greatest or greatest to least. That's important. Also, when in doubt, just divide the numerator, the top number, by the denominator, and that will give you your decimal. If you can't just really easily convert it into either 10 or 100 as the denominator, and then whatever you do to the bottom, do to the top, so that you can. That's an easy way to convert them into decimals also. So hopefully this helped. Again, if you have any questions, feel free to let me know. Even if you can't get on the Google Meet or anything like that, you can always email me. You all should probably have access to my email address. If not, ask your parents. They have it. And yeah, so I'll talk to you later.